Okay, so in the session today, I will introduce you to the use of the software Ansys Fluent. Okay, I already prepared several videos to help you into getting over the different steps, and I will summarize in brief what are these steps now. And please, I encourage you that once you download Ansys Fluent, try to go over these steps. So watch these videos and practice by doing the same things to create your geometry, your mesh, your setup, and try to do a solution just to see how this will work. And after, once you are familiar with the way it's working, we'll go over variable types of applications. Okay, so first, when you download Ansys, all you have to do then is to search for a workbench. Okay, so you go to your computer, you just enter workbench. You should have this application. Okay, it depends on the version you downloaded. It's not important. Download any version you can. All versions share same features nearly. Okay, so when you open this application, it might take some time to open. You double click on it, you open it. Once you open it, you will see this. You will see just this part of your window. Okay, and then you should select the appropriate applications that you have. So here we want to deal with Fluent. You have many other applications. And this software is very powerful. It depends on what is the application you have. In general, when you have a Fluid Flow applications, we deal with Fluent. Okay. For example, here you have applications that are particular to internal combustion engine. So that will be used mainly to simulate the combustion process in an internal combustion engine and how this is happening. You have, for example, other applications. You have, if you have a thermal electric application, you can enter here thermal electric. So you have a lot of applications in Workbench. Mainly in this course, we'll concentrate on Fluid Flow Fluent because it will be related to the content we will deliver in the course material. Now, once you double click on Fluid Fluent, you will have this window that is opened. Okay. Now, already I prepared some steps, and all the steps I did will be posted for you in videos, so you can follow the same steps. But whenever you start, you will have a question mark over all of these steps, saying that you didn't start it yet. Okay, so the first step will be to double click on geometry. Once you double click on geometry, you will have here, depending on the version you are dealing with. Okay, if you are dealing with a new version, you have several possibilities to create geometry, even in Ansys. So if you just do right click, okay, you will have a window that is opened for you, and it will give you options. You can use design modeler, which we will use together now, and you can also use space claim, which is another if you want feature to draw your geometry. At the end, all will work in similar ways. Okay, so you can use this design modeler, you can use the space claim, you can import from AutoCAD, you can import from Inventor. So in this phase, you have several possibilities. Together in this course, we'll go over the design modeler technique. Okay, so you will open this window, and through this processor, you will be able to draw your geometry. You have many other tools, as I told you. If you are interested in them, you can simply Google them, and you will learn how to do it. And it's a procedure to follow. Let us go first through design modeler. So if you double click on geometry, you will open then the following window. And in this window, you have several drawing tools. Okay, because this is very practical issue, what I did is that I already recorded videos previously on how to create a geometry, how to mesh it using Ansys Fluent. So once you download the software, please try to go over these steps again. I will summarize here what you can do in this window. So here you can create the geometry you want. Okay, if you have sometimes complex geometries, if you have a thermal mannequin, for example, you have already if you Google it, you can say, Can I import a mannequin to Ansys?" So you have already created geometries that can be imported to your geometry. This will simplify things on you, because drawing a real thermal mannequin with its curved is very complex, and this will require a lot of advanced drawing techniques. So sometimes you can import some objects and put them in your geometry, or you can build your geometry from zero on Ansys Fluent. And then this is why it's better if you can simplify your things, if you can simulate. For example, in this space, I am drawing an office, okay? And I'm simulating a thermal, an occupant by a cylinder. You can tell me, is it exact? A lot of studies have been done to see if a cylindrical shape can simulate an occupant. Of course, depending on the application, if you are studying thermal comfort of the occupant, it would be better to put the thermal mannequin with its curves, to have the different zones, because in thermal comfort, you should have the head, you should have the, let's say, the torso, the feet. So all parts, each part will be affected by the comfort, and the air conditions at the proximity of each part should be assessed. So whenever we deal with comfort applications, thermal comfort applications, we still can use a cylinder, but the approach will not be accurate as using thermal mannequins. Now, if you are studying cross-contamination in space, it's fine if you use a cylinder instead of a thermal mannequin, because what you care for is how particles are distributed in the space and such things. Okay, so it depends what you want to do, what simplifications can be done or not. And in general, we always try to do validation. We try to validate with uh, already done literature work. So if we have experimental literature data, we can validate with it, or we can do our own experiment to validate. Okay. Now, in this geometry here, for example, it's very simple. I created just a box. And this box represents the room I want to ventilate. I created a cylinder within the room. These tools are very simple to create, because here you have create primitives. You can select any geometrical shape you want. Just you have to specify its features, dimensions. So for a cylinder, for example, you can select the radius and the length. For a box, you just have to give the 3 dimensions, etc. So all of these details will be available for you in pre-recorded videos. In these videos, I will tell you all steps needed to draw these, okay, and follow step by step to be familiar with the technique. And then once I draw my box and I draw my cylinder, let's say I want to have a ventilated room, I want to have an inlet and an outlet. So I should create on my faces sketches. Okay. So here, for example, whenever at the beginning, when you open Design Modeler, you will have 3 basic planes. These are the 3 main planes. And then you can draw, for example, a box. This is my box. This is my cylinder. After I'm done, I want to create sketches on planes. So whenever you want to do a sketch, if you need a new plane, different than the base planes you have. So here you have 3 base planes, okay? So for example, you have one of your inlet outlet on this plane, but the other is on an opposite parallel plane. So what you can do, you need to create this plane. To create it in order to draw on it the sketch you want. So all you have to do then is to define it. Then you do create, and you select plane, new plane. Whenever you do this, you will get a new plane. And now in this plane, you can just click sketching. And when you click sketching, you will have all tools needed to sketch whatever you want. You can sketch a circle, you can sketch a polyline, you can sketch a rectangle. Okay, so you have the freedom to select and then to specify dimensions. So you specify dimensions you need, then you will have your sketch. Okay. So again, as I told you, all details will be provided for you in recorded sessions. And I want you to go over these videos and try to do the same on your own in order to be familiar with how to draw a geometry. Okay. Now, after we do our sketches and we build our geometry, okay, we'll just need to do some operations which are called here, for example, if you just draw a sketch and you don't do what we call imprint face, then when you select this face, you will not be able to select separately the inlet or outlet and the face separately. So in order to separate them, you need to introduce an operation. This operation will be through what we call extrude. You will extrude the sketch, okay? And the type of operation you will select is imprint faces. What do we mean by this? By this, we mean that we want to imprint the inlet or outlet on the wall so that we can select it as a separate body. So now you can try, whenever you draw your geometry, before doing the extrude operation, if you take the face selection tool, this is, here you have several tools. This is point selection, this is edge selection, this is face selection, and this is volume selection, okay? So if you have a face and you want to select it, you will just take this tool, which is face selection. Now, before doing extrude, the extrude operation, when you select this wall, both will be selected as one part. They will not be separate. But here, because I already did the extrude operation, I'm able to select them separately. Okay, so I will do two extrude operation, one for this inlet and another one for the outlet. And now, once I'm done with this, I am ready. I am done with my geometry. Okay, so this is my geometry. I created it. Just one important thing. Sometimes if you have bodies that you are not interested in knowing what is happening inside them. So for example, for the cylinder, which is representing the human body, you don't care about what is happening at the lateral surface inside. Okay, you just care about the exchange between the lateral surface of your cylinder and the environment, because this will affect temperature distribution in the space, because you know that the person will release heat flux and then will affect the temperature around the occupant. So since we don't care about what is happening inside the body, we can remove it. We can what we call the operation, we call it here, we suppress it, because if you keep it, it's not a problem, but then Ansys will try to solve for the temperature inside the cylinder, which we don't need. Okay, so this will increase the computational time and it's not effective. So what you can do is you can suppress a body. When you suppress it, so here, for example, you have two main bodies, the room and the occupant. And as you can see here, you have an X close to it because I just did right click, suppress body. And in this case, you will have, when you select your cylinder now, you will just see its, if you want, you will be able only to select in the mesh its external surfaces. You cannot select it as a body, okay, because it's suppressed. So this is your geometry in summary. So this is a simple case we just considered to see how we can go with the different steps in Ansys. When you are done with so this is your design modeler window. When you are done, you go back to your initial window and you will see that now, instead of the question mark, you will have a green tick near to it telling you that you are done with this part. So once you are done with this part, you move to what we call mesh. So in the mesh, as we mentioned already before, you will divide your space into very small elements. And we have several techniques to test the quality of a mesh. Also, I already prepared before a video on techniques of meshing, how we can test the quality of a mesh, if it's a good mesh, a bad mesh, how we can enhance its quality, how we can see if you want, let's say, how to improve it, what are the techniques that can we use to improve the quality. Mainly, we have face sizing, which means we decrease the size of, we can decrease the size of elements. In this way, we go to finer elements. This is in this way we avoid, if you want, regions. In general, if you have a lot of curves, if you use big size elements, you might not be able to capture the curvature in your space. Okay, and this will give you a bad quality mesh. On the other hand, if you use small elements, you can capture all curvatures, and then when you solve, when you simulate, you will not face problems in these zones. Okay, so now I double clicked on mesh. It takes some time to open. So as I told you, in this part, we will divide our control volume into small parts. Okay, here you have to select what type of elements should be used. So as I mentioned before, you can use, let's say, if you have simple geometry, you can use orthogonal elements. So you can then, you don't need to use tetrahedral elements. If you have a lot of curves, then tetrahedral elements will be better, because as I told you, if you have a curvature and you are using orthogonal elements, you might not be able to trap completely the curvature, because as you can see here, you have straight angles. However, when you deal with tetrahedral elements are more flexible. So as you can see here, they will allow you to capture in a good way the curvature. And smaller the elements you use, the size of elements you use, the better is. So you can trap, if you want, finer zones, and then have better computation. Okay, so one of the best strategies to enhance the mesh quality is to reduce the face size. You can also do what we call inflation. We'll see. So here, the inflation strategy consists of near surfaces dividing the elements into small parts. So like we create layers. Okay, so by layering the zone near the curve, the wall or the curved part, we can deal with smaller elements, and we can trap what we call, we can trap this zone in a better way. Okay, so these are one of the strategies that are used. Again, as I told you, I detailed for you all of these strategies in recorded videos. Just now, I want to give you an overview about the meshing procedure. So here, whenever you open the mesh, you have this tool. Before doing anything, you can generate a, what we call, if you want, a first mesh. Just you click on generate mesh. You will have, if you want, a division of your space according to default features selected by Fluent. So if you don't specify what you want, what are the features that you want, Ansys Fluent will just do it by convention. So it will take default features and then it will use them to create your mesh. Now, if you find that the mesh you created is not of the quality you want to enhance its quality, then you can create new, if you want, you can implement new strategies to enhance the quality of your mesh, etc. Let me check now. So here, okay, look. Here already, I created my mesh, okay? And let me tell you what were the main features I used. So here, when you click on mesh, okay, when you put right click on mesh, you will have different features. You can insert, for example, a method for meshing. You can specify the type of elements you want, as I told you, instead of keeping it by default. You can do what we call phase sizing. So you can impose the size of your elements to enhance your mesh quality. You can do refinement in certain regions. So sometimes you need to create a region where you have finer sizes than other regions. So you do what is called refinement. You have the inflation, which I was talking about. You have several strategies. Okay. Now, when you do these strategies, okay, you can make sure that if you want inflation or phase sizing was done, you can do a cut in your mesh. So here you have a cutting tool, this one. You can cut your mesh wherever you want and observe your mesh. And for example, if you are interested to see how the mesh is around your cylinder, you select this tool, you cut your mesh, and then you observe it. So here I have the rotating tool. I can zoom in a little bit, and I can see, if you want, here, for example, my mesh elements. So it's clear that they are of tetrahedral type, and also I have a fine size. I'm able to capture the curvature of my cylinder, as you can see here. Okay, now I can turn it. So here it's from the lower part. I don't see inflation. To see my inflation, I should turn to inside the domain. Okay, so let me zoom it again and turn it. So this is from inside. This is the view from inside. Okay, look, if I do is zoom in, I can see, for example, some strategies that can enhance my mesh. As you can see here, for example, if I want to capture close to the cylinder what is happening, specifically, from fluid mechanics, whenever you have a flow over the surface, you will have formation of boundary layers, around the surface. So to capture these boundary layers, it's good to have very fine size around, if you want, around the surface of interest. And to do this, or you can do phase sizing, but you will have to, whenever you do phase sizing, in general, you will have to increase a lot the number of elements, because you have to progressively go from very small size to a larger size. So you can see here, as I go far from the cylinder, the size is increasing, because this is my zone of interest, and I can allow for larger size after. But also, this transition should be well studied, because if you suddenly move from very small element to very large element, this will create some divergence problems in your simulation. Okay, so here you have, if you want, the inflation that is clear, where we created several layers around the surface. Another strategy, as I told you, is phase sizing. You can make sure that the size is small on faces and it's increasing progressively. In general, we do not recommend to have very large differences in face sizes, especially for surfaces close to each other, because if you suddenly change the size, this might lead to divergence, because you will suddenly jump from a small to a big size, which will lead to divergence problem. Okay, so you have several strategies to enhance your mesh, and the mesh quality can be assessed through different factors. Also, I explained in recorded videos for you what are these different factors. So you can go to mesh statistics, you click on mesh, you go to statistics, you can read the number of nodes, you can read the number of elements. You can see, if you want, here, if you go down, you have what we call the features. Let me check what it is. So mesh, you have statistics here. You can go down with it. you have what is called mesh metric. Let me check where it is. Okay, so in the quality, okay, you have check the mesh quality. You have the mesh metric. Here in the mesh metric, you have several options. You have a lot of elements, or if you want criteria to test the mesh quality. The main of these criteria are skewness, orthogonal quality, and aspect ratio. So for example, it's recommended that skewness in your domain should be, the maximum should be lower than 0.97. The lower your maximum skewness, the better is. So here, for example, whenever you select skewness, you can see the maximum, the minimum. So you can check that your maximum is below 0.97 or 0.95, which is good. And even you can check zones, and you can check the critical zones here. When they give you this graph, okay, you can see the distribution of elements, know how much elements are characterized by skewness above 0.75, for example. So if you want to know where is the elements having the highest skewness, you just have to double click here. And when you double click here on your figure, they should show you this the zone where you have elements of high skewness. Here, maybe let me zoom it. Okay, so when you do this, they should here, because I already did the cut, it's not clear where to remove the cut. You just have to go to this. Okay, so here you might be able to select your parts because you have already a section plane. Okay, so it's not appearing here, but it should be somewhere below. Okay, when you do a cut, you can remove it again to see your whole space. Okay, so even if you did a cut and you want to go back to your space, you can do it. You have like I don't know why it's not appearing here, but you have a small box that you can select and remove the cut, so you can see again your full mesh. Okay, anyway, so here you can click on zones, and when you click on the zone of interest, you can see the corresponding element. So this is here, you can see it here. So when I clicked on a certain number, because it's already an intermediate number of skewness, you have a lot of element belonging to this range. But in general, when you deal with high skewness, you have limited elements. So you can know in which regions I have problems, maybe, because in regions where you will see elements like this in gray, this means that these elements belongs to this number of skewness. And then when you, let's say, when you deal with the big numbers, you just have few elements, and you can detect the zones, the critical zones. So you can try, for example, when if you click on highest skewness and you get elements around the cylinder, this means that I should try to enhance my mesh around the cylinder in order to avoid reaching high skewness in these zones. Here already the numbers are good. You don't have very large skewness. In case you face large skewness, more than allowable, as I told you, you should double click on the number. You should see where are these elements of which are critical, and try to modify your mesh. So for example, you can refine in this zone. You can use smaller face size. You can try to use inflation, okay, to be able to overcome this limitation. Okay, so we have a lot of techniques to enhance the mesh. I talked in detail about these techniques in the recorded video. So whenever you download Ansys and you try to do this drawing, please try to go over these strategies: face sizing, inflation. Try to play with them to see how they can affect your mesh features. Okay, and then once you are done with your strategies, you just click on update. Your mesh will be updated, and then you can go back to your window here, and now you double click on setup. Okay, And in this part, in the setup part, you will have to, if you want, introduce, it's a very important step. In this part, you will define what are the techniques or models you will use, what are your boundary conditions, etc. So first, when I double click on setup, I will have a window that will open. In this window, I can select, for example, we have several options. If I'm working in 2D or 3D, I can select. I have for options, I can select double precision. So this depends on if you want the precision of my computer and what is the precision I want for my solution. Now, concerning the processing operations options, I can select or serial or parallel. Now, if my computer is a powerful computer with several processors, I can click on parallel, and then I have to select what is the number of processors I want to use. This depends on the capacity of your computer. If your computer cannot withstand, if you want very heavy loads, so you can just keep serial, okay? And then you will say, okay. Okay.
دكتور هولي شرحها details بالrecorded videos.
يا اكيد الجيومتري ومش كثير ان ديتيل. هلا السيت اب هلا حاشرحها ان ديتيل معكم. اوكي لانه هوليك بدهم وقت وبدهم تكونوا منزلين فلوينت وعم تعملوا براكتس at the same time. Okay, look, let me open another meeting to continue the setup part. Okay, يلا please join again.
نفس اللينك ما هيك؟
المفروض let me check إذا try the same link. Okay, try the same link.
Okay.